Hello and welcome to the live session by Infinity Learn by Sri Chaitanya. I am Misbah, your maths educator, and in this class we are going to do the remainder theorem and the factor theorem. So are you guys ready? Just let me know that in the chat, guys. In the previous session we have done zeros of a polynomial and the some questions on the basis of them, and now in this session we are going to do the remainder theorem and the factor theorem. So let's wait for some more seconds, let other students join as well, and then we'll be starting with this session. So are you guys ready? Just comment in the chat, guys. Am I audible and visible to you? Okay, so let's start with it, guys, with the remainder theorem. So if p of x is a polynomial of degree greater than or equal to 1 and p of x is divided by a linear polynomial x minus a, then the remainder is p of a. This is called the remainder theorem. For example, if I have got a polynomial of degree greater than or equal to 1. So suppose I am taking a 3-degree polynomial over here, a cubic polynomial. Suppose I have got this polynomial, right? And I want to divide this polynomial by a linear polynomial. Suppose I want to divide this polynomial by a linear polynomial 2x plus 1. So what will be the remainder? So in order to find the remainder, when you divide this polynomial by this linear polynomial 2x plus 1, what we need to do is put this linear polynomial equal to 0. From here you can find the value of x, that is equal to minus 1 by 2. Now put x is equal to minus 1 by 2 in the polynomial. So p of minus 1 by 2, this is the remainder and this is the remainder theorem. So remainder will be minus 1 the whole cube minus 3 into minus 1 the whole square. Whatever may be the answer, guys, you can do the calculation. 2 into minus 1 by 2 and minus 1 over here. So that is the remainder. I hope this is clear to you. So that is the remainder, and that's how you find the remainder when you divide a polynomial by a polynomial whose degree by a linear polynomial. I hope that is clear to you. Any doubt in this thing, guys? So basically you have got a polynomial and you are dividing it by a linear polynomial 2x plus 1 and you want to find the remainder. So again I am saying what you will do, put this linear polynomial equal to 0. So you will get x is equal to minus 1 by 2. Now put x is equal to minus 1 by 2 in the polynomial itself, and that is the remainder by the remainder theorem. Okay, Aisha, right? Now because this is simple, if you use the actual long division method, finding remainder will be very complex. It will take time. I mean, you have to do the long division. You have studied the long division, guys. You must have done this. Suppose if you don't know the remainder theorem, you will divide the given cubic polynomial over here by the linear polynomial like this 2x plus 1. Now you will do the long division over here. So will it not take time, guys? So therefore remainder theorem makes it very easy for you to find the remainder when you divide a polynomial by a linear polynomial. Again I am saying this is happening in case of a linear polynomial only. You don't have this type of thing where you are not dividing by a linear polynomial. Although I will give questions on the basis of them as well. When you are not dividing by a linear polynomial, in that case how can you find the remainder? Is it clear to every student in this session? Just confirm that in the chat, guys. I hope it is clear to you, right? So basically if you have got any polynomial p of x, and you are dividing it by any linear polynomial ax plus b, where a and b are variables, right? So in order to find the remainder, what do? Put this polynomial equal to 0. From here you will get x is equal to minus b by a. You will get minus b by a. So just put x is equal to minus b by 2 in the polynomial itself. Put it minus b by a. Sorry. So this will be the remainder, and this is coming from the remainder theorem itself. I'm just saying, okay, no problem, KV Vlogs and Kotaro. I'm just understand over here properly. Suppose you have got a polynomial p of x whose degree is greater than or equal to 1. You got it? It is a linear polynomial, a quadratic polynomial, or a cubic polynomial, anything like that. degree is greater than equal to 1, and you are dividing that polynomial by a linear polynomial. You got it? This is a linear polynomial. You are dividing this by this. So the question is, how will you find the remainder? You got that question, KV Vlogs and Kotaro? So what you will do, put this linear polynomial equal to 0. Put this linear polynomial equal to 0. From here you will get x is equal to minus b by a. Correct? Now put x is equal to minus b by a in the polynomial itself. That will be the remainder according to the remainder theorem. Hello time pass. Is it clear? Aisha, KV Vlogs, Kotaro, time pass. Tell me. Any doubt in this thing? Now another example which I had already explained over here. Suppose you have been given with a cubic polynomial over here and you are dividing it by a linear polynomial 2x plus 1. How can you find the remainder? Hello Kavita, good evening. So obviously if you will do the actual long division method, it will waste your time. Then also you will get the correct answer, but it will waste your time. So when you are dividing this cubic polynomial by a linear polynomial, you want to get the remainder. So what you will do? First put this linear polynomial equal to 0. Put this linear polynomial equal to 0. You will get x is equal to minus 1 by 2, correct? You will get x is equal to minus 1 by 2. Now put x is equal to minus 1 by 2 in the polynomial itself, in this polynomial itself. So you will get this value and this is the remainder. I am not simplifying. You can do that. I hope it is clear. It's okay, time pass. Is it clear, Kotaro, KV Vlogs? Any doubt in that? Is it clear, Kavita? So that's how you find the remainder using the remainder theorem. When you are dividing a polynomial whose degree is greater than equal to 1 by a linear polynomial, and this statement is called the remainder theorem. Right? So let us do some questions on the basis of this. So find the sum of remainders when you divide this polynomial by x minus 1 and x plus 2. Can you tell that? Okay, Aisha, try doing this one and let me know the answer over here. Just do that, guys. So you have to find the sum of remainders when you divide this polynomial by x minus 1 and x plus 2. Suppose the polynomial over here is p of x. Just name it p of x, right? If you divide this polynomial by x minus 1, what will be the remainder? Suppose I am showing that remainder by r1. Okay. So remainder 1, will it be p of 1, guys? Tell me. That will be p of 1. So in this polynomial, put x is equal to 1. So 1 cube minus 3 into 1 square plus 4 into 1 minus 4. If you simplify, what will you get over here, guys? You will get minus 2. That is minus 2. Right? Now if you divide this polynomial p of x by x plus 2, what will be the remainder? Suppose it is r2. So remainder will be p of minus 2 or not. It means in the polynomial, in place of x, we have to put minus 2. So just simplify and get the answer. Minus 2 we have to put over here, plus 4 into minus 2 minus 4 over here. So let's simplify what we are getting. So this is minus 8 and this will be 4 minus 12 and this will be minus 8 minus 4. So what we are getting over here, guys? Minus 32. We are getting minus 32 over here. Is it clear? Now we have to find the sum of these two remainders. That is being asked in the question. So r1 plus r2 we have to find. So r1 over here is minus 2 and r2 over here is minus 32. So we are getting over here minus 34. Is it clear to every student in this session? Minus 32 we are getting, Aisha. Just check it over here. We have put minus 2 in this case. So you see minus 2 will come over here and then simplify minus 8, 4 3s are 12. That is correct only. Minus 8 minus 4. So this will be negative only. That is correct, Aisha. I hope it is clear to every student in this session, right? Is it clear to every student? Aisha, KV Vlogs, Kotaro, Time Pass, Kavita. Any doubt in this question? So you have to find the sum of the remainders when you divide this polynomial by x minus 1 and x plus 2. Is it clear, guys? Okay. So let us do some more questions over here, guys. Find the remainder obtained when this is divisible by this. Now you see, this question you cannot do directly using the remainder theorem. Because you see, you're dividing this polynomial by a polynomial which is not a linear polynomial. You got that? Many a times you can get this question as well. It is not normally in your school syllabus, but in competitive examinations you'll get this question, right? This type of question many a times. You see, over here you cannot use the remainder theorem because the polynomial by which you are dividing, it is not a linear polynomial. So you cannot use the remainder theorem. So can you tell me how will we do this question? Aisha, KV Vlogs, Kotaro, Kavita. Can you tell that, guys? Over here we will not be able to use the remainder theorem because the polynomial by which we are dividing this polynomial is not a linear polynomial. So what we can do, we can use the division algorithm. Have you studied division algorithm, guys? Dividend is equal to divisor into quotient plus remainder. The first thing which you have to understand very clearly in your mind, you are dividing by a quadratic polynomial. It's a 2-degree polynomial. You are dividing by a quadratic polynomial, then remainder will be a linear polynomial. You got it? You have to assume the remainder to be a linear polynomial. And this is the standard form of a linear polynomial, ax plus b. You got it? Whenever you are dividing by a quadratic polynomial, the remainder will be a linear polynomial. It's not compulsory that every time you'll get a linear polynomial. The reason being, suppose this is a factor of this, what will happen? Just suppose, not in this case, this is a factor of this, then the remainder will be 0 now. You got the logic? When the divisor is a factor of the dividend, in that case remainder will be 0. Okay? But suppose that is not the case, then the remainder will be a linear polynomial. Suppose this is a quadratic polynomial, we are dividing by a quadratic polynomial, you have to assume the remainder to be a linear polynomial. Suppose you are dividing by a cubic polynomial, you have to assume the remainder to be a quadratic polynomial. You have to assume the remainder whose degree must be 1 less than the degree of the divisor. I hope it is clear. Now you have studied the division algorithm. You are dividing this, so this is dividend. Dividend is equal to divisor. This is the divisor, guys. Divisor into quotient. You don't know the quotient, right? Suppose it is q of x. You don't know the quotient. Plus remainder. Remainder you have to assume in this form, ax plus b. I hope this is clear. Dividend is equal to divisor into quotient plus remainder. I hope that is clear. Now can you tell me what are the zeros of this polynomial? X square minus 1 can be written as minus 1 square. So this can be written as x plus 1, x minus 1. You can use a square minus b square identity over here. I hope that is clear. So the zeros of this polynomial are plus minus 1. The zeros are plus 1 and minus 1. Correct? So what we have to do over here, first we have to put 1 0, that is x is equal to 1. So I am putting x is equal to 1. Obviously you have to do it on both the sides of this equation. So it will give you what? 1 square minus 1 into qx plus a into 1 you will get over here, right? A into 1 plus b. So this is the first equation you will get. See, 1 square minus 1 is 0 only, so this will vanish out. And this is only 1. So what equation you will get over here, guys? You will get a plus b is equal to 1. This is the first equation. I hope that is clear. Now if you will put the second 0 of this polynomial, the second 0 is minus 1 over here. So you will put x is equal to minus 1. Let us put x is equal to minus 1. So what you will get? Minus 1 raised to the power 2007. That is equal to minus 1 square minus 1 into the quotient, that is qx over here, plus a into minus 1 plus b. I hope that is clear to you, right? So you see minus 1 raised to the power 2007 will be minus 1 only, right? And this will vanish out because this will be 1 minus 1 0, and what you are getting? Minus a plus b. So you will get from here minus a plus b, that is equal to minus 1. This is the second equation. This is the first equation, and this is the second equation. So basically you have to solve these two equations to get the values of a and b. I hope it is clear. Hello Pranav, good afternoon. Exactly. So we have to solve these equations to get the values of a and b. So what I can do, can I eliminate a? Can I add these equations? You see, can I add these equations over here? So what will I get after adding? You see, it is plus a minus a, it will be cancelled out. So you will get 2b over here. See, you will get 2b, and that is equal to what? 1 minus 1. If you add them up, 1 minus 1 will be 0. So basically this is 0. So the value of b is coming out to be 0. Value of b is coming out to be 0. So if you put b is equal to 0 in this equation, suppose b is equal to 0, if you will put, what will you get? You will get a plus 0, that is 1. So from here you will get a is equal to 1. So what is the remainder, guys? The remainder was ax plus b. So a we are getting to be equal to 1 and b we are getting to be 0. So the remainder is x. It means if you divide x raised to the power 2007 by x square minus 1, the remainder will be x only. Is it clear to everybody in this session? So this type of questions can also be asked, but not obviously in your school examinations. In your school exam, you'll every time get a question in which the divisor is a linear polynomial. But in competitive examinations, you can get questions in which the divisor is a quadratic polynomial, is a cubic polynomial. It can happen like that. Square root of x square is modulus of x. It is grade 9 mathematics, Simon. Utkarsh, square root of x square is equal to modulus of x. It can never be negative. I hope you understand that. Okay. I hope this is clear to every student in this session. Okay, let's move on to the next thing. Now we have got the factor theorem. So basically factor theorem is a special case of the remainder theorem only. Factor theorem? No, it's not like that, Aisha. See, what you have to do when you're studying a concept for the first time, just practice as many questions as possible, and there must be a pattern, following which you have to practice. Just don't do random questions. For example, take a standard textbook, maybe R.D. Sharma, maybe R.S. Agrawal. Just do small questions first. You got it? So if you will do a plenty of small questions first, then you can increase the level like that. Don't go to very tough questions just after doing 2-3 small questions. You got that or not? So in that manner, your logic will build and automatically everything will be okay. If you do this in even 2-3 chapters, you will see that there is a difference in your perception of mathematics. I hope it is okay with you. Okay, so basically factor theorem is a special case of remainder theorem. I'll explain with numbers, you will understand with numbers. Right now I'll not talk about polynomials. You see, for example, just take it over here. 15 if I'm dividing by 2, okay. 15 I'm dividing by 2, 2 sevens are 14, remainder is 1. You got it? 15 I'm dividing by 2, remainder is 1. Got it? But suppose I'm dividing 16 by 2. So you see 2 8s are 16, remainder is 0. You got it? What does it mean? If I am dividing 16 by 2, I am getting remainder equal to 0. So what do we say? We will say that 2 is a factor of 16. Yes or no? We will say 2 is a factor of 16 because we are getting remainder to be equal to 0. Is that correct with you? Is that correct, guys? If I divide 16 by 2, the remainder is coming out to be 0. Therefore, I will say 2 is a factor of 16, or you can say 16 is a multiple of 2. That is the definition of factors and multiples, right? In the same logic, if suppose you have got any polynomial whose degree is greater than equal to 1, and if you are dividing it by, see, if p of x is a polynomial whose degree is greater than equal to 1, and if it is given that already x minus a is a factor of p of x. You got that logic? X minus a is a factor of p of x is already given. What does it mean? That if I divide this polynomial by x minus a, the remainder must be 0. That is the definition of factors and multiples. Got it? Now what is the remainder? That remainder is p of a or not, using the remainder theorem which we have studied right now. So what can I say? If x minus a is a factor of p of x, then p of a is equal to 0 or not? Tell me. So isn't it a very different thing? I would say no, it's not very different. It is just a special case of the remainder theorem. Again I am repeating, if x minus a is a factor of p of x, What does it mean? It means that if I divide p of x by x minus a, the remainder must be equal to 0. Now what is the remainder if I divide p of x by x minus a? The remainder is p of a, which we have studied today itself in the remainder theorem. So what I would say, factor theorem is a special case of the remainder theorem, right? Now the second part, if p of a is 0, it means x minus a is a factor. It is opposite of the same thing. If for this polynomial it is suppose given that p of any number k is 0, if this is given, then can I not say that x minus k is a factor? Tell me. It is the same thing, but it is the converse of it, right? Converse of it, right? So is it clear to every student? Aisha, KV, Vlogs, Pranav, is it clear? Utkarsh, Simon, any doubt in this thing, guys? Tell me. So that is the meaning of factor theorem over here. It's a special case of the remainder theorem only. I hope it is clear to every student over here. So let us do some questions over here. Can you do this one? If it is given that px plus q is a factor of h of x, then which one is true? Can you tell me, guys? Which out of the given options is true over here? It's a very basic question on the basis of factor theorem. Can you tell the answer over here? So over here it is given that px plus q is a factor. So if px plus q is a factor of h of x, it means that if I divide h of x by px plus q, the remainder has to be 0. Now how will I find the remainder when I am dividing h of x by px plus q? You have studied the remainder theorem. I will put this polynomial, the linear polynomial, equal to 0. So I will get x is equal to minus q by p, correct? So according to the remainder theorem, the remainder has to be h of minus q by p, correct? This is the remainder when I am dividing h of x by px plus q, but it is already given that this is a factor of this. So therefore the remainder has to be 0 or not. So therefore option D is correct over here. Very good, simple question. Is it clear to every student over here? Option D is correct. It's a very simple question. I hope there is no doubt in this on the very basic definition of factor theorem, or you can say remainder theorem as well. Any doubt in this, guys? Okay, Mayuk. Let's move on to the next one. Can you try doing this one? It is the opposite of the previous question only. If h of x be a polynomial such that h of minus 1 by 3 is equal to 0, then one of the factors of h of x is what? One of the factors of h of x is what? Tell me. Can you tell the answer to this question, guys? Aisha, KV, Vlogs, Pranav, Shashi, Utkarsh, Simon. Okay, very good. Okay, Mukesh, Aisha, Mayuk, that is correct only, right? So you see h of minus 1 by 3 is 0. It means what I can say? That x plus 1 by 3 is a factor or not? Tell me. Got that logic? H of minus 1 by 3 is 0. It means x plus 1 by 3 is a factor. You can also manipulate this, take the LCM. You can also say that 3x plus 1 by 3 is a factor. You can also say that 3x plus 1 is a factor. You got that logic? So therefore option B is correct. See, if for a polynomial x plus 1 by 3 is a factor, automatically 3x plus 1 is also a factor of that polynomial. Correct or not? Is it okay? You can understand it like this. Suppose I've got a polynomial which is x plus 1 by 3 and suppose it is anything x plus 2. So guys, you see x plus 1 by 3 is a factor of that polynomial. If you simplify, you'll get 3x plus 1 into x plus 2 the whole divided by 3 over here, correct? So you see automatically 3x plus 1 is a factor, is also there. I hope that is clear. It's a very simple question, right? Let's move on to the next thing. Can you do this one, guys? If y plus 2m is a factor of this polynomial, can you find the value of m over here? Try doing this one. Let me know the answer over here. So on the very basic definition of factor theorems, right? Directly you just have to put the value. If h, so you will say what? See, if h0 is 0, if h0 is 0, it means you can understand it like this, that x minus 0 is a factor or x is a factor. You got it, Aisha? Got it or not, Aisha? Simple. It means x is a factor of that polynomial. I mean, in whatever variable the polynomial is. Suppose the polynomial is in variable y, then y is a factor of that polynomial, right? I hope you got it, Aisha. Okay, so let us do this question over here, guys. So it is given that y plus 2m is a factor of this polynomial, then we have to find the value of m. Suppose the name of this polynomial is p of y, because it is in variable y, p of y, right? So if we are dividing the polynomial by y plus 2m, right? So what I have to do, and it is given that this is a factor of p of y. So can I not say that p of minus 2m is equal to 0, yes or no? Tell me, guys. P of minus 2m is equal to 0 because you are dividing this polynomial by y plus 2m, and it is given that y plus 2m is a factor of this polynomial. So p of minus 2m is equal to 0. It means in this polynomial you have to put y is equal to minus 2m. Let's do that. So minus 2m raised to the power 5 minus 4m square y minus 2m raised to the power 3, and then you have got 2 into minus 2m, and then you have got plus 2m plus 3 is equal to 0. Correct? So it is looking complex, but it is very simple. You will see it within seconds, you will understand it, right? So let's do it. Now this is minus 2m raised to the power 5. If you simplify, you will get minus 32m raised to the power 5. And you see this will be minus 8m raised to the power 3, minus 8m raised to the power 3. And if you simplify this, you will get plus 32m raised to the power 5. I hope that is clear, because you see this part will give you minus 8m cube. Now if you multiply minus 8m cube and minus 4m square, you will get plus 32m raised to the power 5. And this is minus 4m plus 2m plus 3, that is equal to 0. So from here you see we will cancel out this. I hope that is clear. Now you see this is minus 4m plus 2m. So we will get minus 2m plus 3 is equal to 0. So from here if you simplify and solve this equation, you will get m is equal to 3 by 2. So m is equal to 3 by 2 is the answer. Is the question clear to every student? Mukesh, Aisha, Utkarsh, Prasanna. Exactly, option B is correct over here, Mukesh. Is it clear, Aisha, Prasanna, Mukesh, Utkarsh, Sunil, Mayuk? Any doubt in this question? A very basic question on the very basic definition of factor theorem. It is looking like complex. Why, Bimla? Okay, maybe you have joined in between. So Bimla, we have studied this factor theorem. It is given that y plus 2m is a factor of this polynomial. So suppose the name of this polynomial is p of y. Okay, Bimla? Now if for this polynomial y plus 2m is a factor, so I can say the name of the polynomial is p of y, then we can say that p of minus 2m is equal to 0. You got that you got that, Bimla? We have studied today itself. So it means in the polynomial we have to put, in place of y we have to put minus 2m, and then if you will simplify you will get the value of m to be equal to 3 by 2. Is it clear, Bimla? Okay, KV Vlogs. Is that clear to you? And obviously, needless to say, watch the recording, just go back a bit, you'll get it for sure. You will get it for sure, right? I did explain in very detail. Now, can you tell me what is the answer to this question? Find the sum of remainders when this polynomial is divided by, I guess we have already done this, right? There is a mistake. We have already done this question. Yes or no, guys? We already have done this question today itself. Yes or no? Yep. So now this is a bit different type of question, which actually I must have taken in the previous session, but actually we were not able to do in the previous session. Therefore, I am taking this question over here. Can you try doing this and let me know the answer? It is a good question over here, guys. If p of x is equal to x cube minus 3x square plus 2x plus 5, and it is given that p of a is equal to p of b is equal to p of c is equal to 0, then can you find the value of 2 minus a, 2 minus b, 2 minus c? Can you try doing this and let me know the answer over here? Try doing this question and let me know the answer, guys. So basically you have studied this thing. Over here the very first thing is, it is given that p of a, p of b and p of c is 0, right? So if you will try to actually put the value of x to be a, and if you will put the value of x to be b, and if you will put the value of x to be c, it will waste your time. I mean, it will take, I don't know, maybe if you will not get the answer as well, it will make it very complex, right? So basically we can use the basic definition of a polynomial. See, what does it mean? If p of a is given to be 0 and p of b is given to be 0 and p of c is given to be 0, can we not say that a, b and c, these are zeros of this polynomial? Can we say that, guys? If p of a, p of b, p of c, it is given to us, can we not say that a, b and c are the zeros of this polynomial p of x? Is it clear to everybody? So can we not write this cubic polynomial? So it will have maximum 3 zeros only, 3 real zeros only, right? So we can write the polynomial like this or not? X minus a, x minus b, x minus c. Can we say that, guys? Yes or no? Can we write the polynomial p of x like this or not? Because a, b and c are the zeros of that polynomial. It is given over here. And one more thing. You see, the leading coefficient is 1 over here. The leading coefficient, the coefficient of the highest exponent of the variable. So over here as well only 1 will come up, right? I hope that is clear. Now over here one more thing, guys. So this is equal to the polynomial or not? This is nothing but the polynomial itself. Now you see, we have to find the value of 2 minus a, 2 minus b, 2 minus c. It means what is being asked? It is being asked that in the polynomial itself you have to put x is equal to 2. So if you will put x is equal to 2 in the left hand side, you have to do that in the right hand side as well. So it is 2 minus a, 2 minus b, 2 minus c. So we have to find the value of basically p of 2. You got that logic? 2 minus a, 2 minus b, 2 minus c means that we have to find the value of p of 2 only. That is the question. So how will you find p of 2? The polynomial is already given to us, na? See it properly. The polynomial is already given to us. So we can put x is equal to 2 in this polynomial. That's it. So it will be 2 cube minus 3 into 2 square plus 2 into 2 plus 5. That will be the answer or not? Tell me. If you simplify, you see this is 8 minus 4 3s are 12 plus 4. So basically these will get cancelled out and you'll get the value to be equal to 5. P of 2 is coming out to be equal to 5. It means the value of 2 minus a, 2 minus b, 2 minus c is also 5, because this is also equal to p of 2 only. So therefore 5 is the answer. Is it clear to every student over here? Maybe you have joined in between SR Kushwaha. Obviously it will not happen if you haven't studied the previous things. Obviously you can understand that. No, this is an Olympiad question, Utkarsh. This is not in NCERT for sure. And it will never come in your school examination, that is 100% sure. But obviously we are talking about some extra things as well. I am explaining once again SR Kushwaha over here. See, if it is given over here that p of a, p of b, p of c, that is equal to 0. So can I not say, according to the basic definition of zeros of a polynomial, can I not say that a, b and c are the zeros of the polynomial p of x? Tell me. That is the meaning of zeros, right? So if a, b and c are the zeros and it's a cubic polynomial, so can I write the polynomial like this? Tell me, SR Kushwaha. Can I write it x minus a, x minus b, x minus c? And also you can check the leading coefficient. That is 1 only. So over here as well you will get 1 only over here. I hope that is clear. Now we have to find the value of 2 minus a, 2 minus b, 2 minus c. What does it mean? If I put x is equal to 2 over here, So that will be P of 2. So you have to do the same thing in the right hand side as well or not. So you will get 2 minus A, 2 minus B, 2 minus C. It means the value of 2 minus A, 2 minus B, 2 minus C is nothing but equal to P of 2 only. You got it? It is equal to P of 2 only. Now see, the polynomial is already given to us now. So can I not put the value of x over here and we will get the value of P of 2? That's it. So just put x is equal to 2 and simplify. You will get P of 2 to be equal to 5. And 2 minus A, 2 minus B, 2 minus C was already equal to P of 2. So therefore its answer is, its value is 5. Is it clear to everybody? I hope it is clear, Naval. Any doubt in this question? So basically it was an Olympiad question. I don't remember from which Olympiad, because I think it is from maybe NMTC, something like that. Although I'm not sure about that. Okay. So that's all we needed to discuss in this class. In the next session as well, on the Infinity Learn class 9 and 10 YouTube channel, we will do the subsequent portions of this chapter. For grade 9 students, Pratham series is going on the Infinity Learn class 9 and 10 students, on the Infinity Learn class 9 and 10 YouTube channel. And for grade 10 students, we are conducting Pioneer series. So don't forget to like, share and subscribe. And also don't forget to subscribe to the Telegram channel as well. We'll meet in the next class, guys. Bye-bye. Take care, everybody.